Blowing fuse. You're going to write a program to predict whether a specific usage pattern of electrical appliances will cause the main fuse to blow. You have 3 pieces of data. Number 1. There are n appliances in a room. Each of them has an electrical current consumption value. Number 2. A usage pattern. You will click the power buttons of a list of appliances in a sequence at most m clicks. Each click on a button will toggle the power status, which means when the power is off, a click will turn it on. Clicking it again will turn it off. Number 3. The capacity of the main fuse C in amperes A. The fuse will be blown if the sum of the consumed current of turned on devices at some point exceeds the capacity of the main fuse C. At the beginning, all appliances are off. I'm not going to use PHP, I'm going to use Python. So for input, the first line is separated by a space. The next line is a for loop. Actually, never mind. It says it. Okay, so the first integer n is the number of devices. Assume the devices have IDs from 1 to n. M is the number of button clicking going to happen. And C is the capacity of the main fuse in amperes. Line 2 is the first for loop. Is n integers space separated representing the electrical current consumption value of each appliance, listed from ID 1 to n. The third line, which is the second for loop, is m integers space separated, a sequence of ID hashtag you're going to click power buttons that will toggle the device status in that exact sequence. And for output, the first one is if the fuse was blown during the operation sequence, output one line fuse was blown. And the second output is if the fuse did not blow, find the maximum consumed power by turned on devices that occurred during the sequence. Output 2 lines. Fuse was not blown and maximum consumed current was A. For examples of test cases for the expected format, which is blown, not blown, single device, more devices, more clicks, more devices, and power hungry. Constraints: N and M are below 100, C is below 10,000. So for example, input is 5 to 10, 11, 6, 11, 10, 10, 3, 3. Then output is fuse was blown. Alright, let's do it. Right, so let me do that again. Right, okay, so the three integers value are taken from the input using input in the first line. Split divides them into n, m, and c variables. The variables n stand for the number of devices, m for the frequency of on and off cycles, and c for the highest permit current consumption. The next line assigns L with a list of integers representing the device's respective power consumption levels as received from the input. Every item in the list input returned by the map method is treated as an int object. Divide produces a new list after unpacking the output iterable. Several variables that will be used later in the program are initialized in the following few lines. To keep track of the devices that are on at any given moment, an empty list is used. R will be used as a flag to determine whether the fuse has blown and is originally set to 0. Usage will be used to track the total current consumption at any particular time and is initially set to 0. The total current consumption for each stage in the sequence will be kept in B, an empty list. So this for loop reads m integer values from the input one at a time and processes them to simulate turning the devices on and off. For each value mx, it is added to the used list to indicate the corresponding device has been turned on and off. If mx appears an odd number of times in use, it means the device has just been turned on and its power consumption level should be added to the current consumption. Otherwise, the device has just been turned off and its power consumption level should be subtracted from the total current consumption. The B list, which keeps the track of the overall consumption for each step, is updated at each step with the current total consumption. Finally, the R flag is set to 1 to denote that the fuse has blown if the current total consumption surpasses C. Finally, depending on whether the fuse has blown or not, the program prints the proper message. The maximum consumed current is determined as a maximum number in the B list and is included in the output message if R is 0, which denotes that the fuse has not blown. The program outputs a fixed message if R is not 0 because that indicates that the fuse has gone.